In this video, I'm going to show how to execute a life simulation in AutoLion-1D. With this capability, you can run simulations with any set of parameters, including material combinations, form factors, and internal cell designs to better understand how these factors influence the overall life of a battery. In AutoLion-1D, charge-discharge cycling is used to age the cell and is controlled by selecting the CC Cyc Life option in the Operating Conditions drop-down menu. As it comes up, you'll see the various options with which to control the cycling. Besides the basic controls for charge and discharge current, there are also controls for the in-cycle characterization. This feature will periodically pause the cycling and perform a characterization to identify the capacity of the cell at that particular instance. In this example, we'll use a C/10 characterization discharge current at a frequency of every 250 cycles. We also have the options to continue where a previous simulation left off. All we have to do is load the correct state.dat file and select the cycle from which we'd like to start. Finally, at the end here, we have the total number of cycles to be run during the simulation. Once the cycling is set up, we can come down to the degradation node where we'll turn on the aging mechanisms for the cell during the simulation. As you can see, there are nodes for the film growth and active material isolation of both the positive and negative electrodes, each of which has an option to be turned on or off. In this example, we'll turn everything on, and you can further see that for each option, we have the option to modify the various parameters which contribute to the film growth and material isolation, respectively. When everything is ready, we'll get set to run the simulation. Depending on the nature of the cycling, the simulation could take between several hours and several days. If the simulation might be on the longer side, it may be beneficial to set the output frequency to 0. This will speed up the simulation by only writing output data to the state.dat file and the decap file if any in-cycle characterization is completed. So we'll run the simulation and we can see that the characterization begins after the first cycle. Once the initial characterization is done, cycling will commence until the next characterization comes along in 250 cycles. While this process is running, we can open the state.dat file and see that the battery state is being recorded after every cycle. This can be used for post-processing later on to analyze the SEI layer growth, power capabilities of the aged cell, and so on and so forth. In another video, we'll take a more detailed look at the options for post-processing and how you can get the most out of each simulation. Thanks for watching.